Every mammal on Earth is covered in fur. Every single one. Except us. Humans are basically naked apes. But here's the weird part. We didn't lose all our hair. We kept it on our heads, under our arms, and in a few other very specific places. So why did evolution strip us bare almost everywhere else, but leave those spots untouched? The answer says a lot about how our ancestors survived. And it starts with something you do every single day without thinking about it. Sweating. About 2 million years ago, our ancestors faced a problem. Early hominins like Homo erectus were starting to hunt on the open savannas of Africa, under brutal sun in extreme heat. And most mammals deal with heat the same way. They pant, like a dog. But panting is slow. It doesn't cool a large, fast-moving body fast enough. If you're chasing prey for hours under the African sun, overheating isn't just uncomfortable, it's deadly. So evolution needed a better cooling system, and the answer was sweat glands, specifically eccrine glands, which release watery sweat directly onto the skin, where it evaporates and pulls heat away from the body. Humans have up to 5 million of these glands. Chimpanzees, our closest relatives, have far fewer, and they're mostly useless because they're buried under thick fur. And that's the catch. Sweat only works if it can actually evaporate off the skin. Thick body hair traps moisture and heat close to the body. It basically ruins the cooling system before it even starts. So the theory goes, as sweat glands became more important for survival, the fur covering most of the body became a liability. Individuals with less hair could cool down faster, run longer, and hunt more effectively. Over generations, that advantage won out, and body hair thinned dramatically. This connects directly to something called persistence hunting, a strategy some human groups still use today. Instead of outrunning prey in a sprint, which we're bad at, early humans would chase an animal for hours, sometimes most of a day, in the hottest part of the afternoon. Animals like antelope are much faster than us, but they cool down by panting, and panting doesn't work while running at full speed. Eventually, the animal overheats and collapses from heat exhaustion, while the human, sweating instead of panting, can keep going. Losing our fur wasn't just about comfort. It may have been the evolutionary trick that let us out-endure animals far faster and stronger than we are. So if less hair meant better cooling, why do we still have hair on our heads? The most widely accepted idea is that scalp hair protects us from something fur elsewhere doesn't need to worry about: direct sun exposure on the skull, where blood vessels sit close to the brain. Thick hair on top acts like a built-in sun shield, reducing the risk of heat stroke on the one part of the body that really can't afford to overheat. As for underarm and pubic hair, researchers think these patches likely stuck around for a completely different reason. They trap pheromones and reduce skin-on-skin friction, which may have played a role in attraction and reproduction. Some scientists also point to these areas as early warning zones for parasites, since coarser hair here made it easier to spot and remove things like lice. Here's the clever part. We don't have fossils of ancient human skin. So how do scientists even date when this happened? The answer is lice. Human body lice evolved specifically to live in clothing, not skin, which means they could only have appeared after humans started wearing clothes, which, in turn, only makes sense once we'd already lost most of our body hair and needed something to keep warm. By comparing the DNA of head lice and body lice and calculating how long ago they split into separate species, researchers estimated that humans were already relatively hairless somewhere between 1 and 3 million years ago, earlier than many expected. So the next time you're sweating on a hot day, that's not a design flaw. It's one of the most important adaptations in human history. It let our ancestors outlast animals that could outrun them, and it's part of the reason we survived long enough to be here at all. If you found this fascinating, subscribe for more, and let me know what human quirk you want explained next.